everyone, I hope you all are doing great. So today we'll be doing the conversion of galvanometer to the ammeter. As in previous lecture we have studied the device that is galvanometer in detail. What is the working principle of galvanometer, how galvanometer equation is created. These all things we have covered in our previous lecture. But today we'll be doing the conversion, how to convert the galvanometers into the ammeter, how to convert their schematic system, how to convert the voltages. So that we're going to study in today's lecture. First of all, to convert a galvanometer to the ammeter, we need to first take a device. Let's say we do have a device. This is a current that is moving in this direction. Let's consider this current as Ig. Okay, now what we're gonna do, we're gonna attach a resistor to it. This resistor could be anything. This resistor could be the bulb that we can attach it. This resistor could be any device that we're gonna attach. So here we're gonna attach a device in parallel. This thing you need to note down, this thing what we are doing here, we are attaching the device in parallel. Okay, second thing that we need to make sure is that we are attaching a galvanometer with it. This is a galvanometer, let's say. Okay, the line in behind, let's recreate it. So to recreate this one, okay, so galvanometer is showcased by this symbol. So you just need to make sure you know the basic things. Well, here, let's say the current flowing in this direction, we have denoted it as Ig. Okay, now the current that went through this side, the transfer of the current, since we know whenever we are studying the parallel connection of the circuit, so we need to keep this in mind that in parallel circuit voltage doesn't change, voltage remains same. However, the flow of current, the I always varies. This varies. But whensoever we are studying the same concept, the same thing in series, so in series, always the current remains same. However, the voltage always varies. So, following up this basic concept, the current will vary. That means that, let's say, the current that is going to this side is I, and we'll cancel out the Ig from it, since Ig is the total current flowing from the circuit. However, some amount of the current is going to this circuit, to the resistor that we have attached. So we'll denote that as I minus Ig. Now, back to the concept. Now, let's say this resistor is Rs, the resistor of the resistance, the value of the resistor, and the resistor that is attached, let me write this point, the resistor showcase two things. First of all, the property of the resistor would be what? This resistor, this specific resistor that we have attached here in the series, represents a special type of resistor that is called shunt resistor. Shunt, and I'm just writing here R, so you can just figure this thing out. Second thing that you need to make sure, and this is a really conceptual thing, that the resistor that we'll attach here would be of low resistance, low value of R. So I have denoted it as RS. And one more thing, that we will be having Rg as well, the resistance that is created by the galvanometer. So we'll denote it as Rg. Now, how many factors we have written? Let me just remove this thing out. I hope that you have written this whole thing. So how many factors we have taken? First, we have taken, let's say, we have taken Ig. That represents what? That represents the total current, total I. The total I that is passing through the galvanometer. In addition, it corresponds to the full scale reading. Okay. Second thing that we have taken is Rg. Rg is what? The resistance of what? Of galvanometer. Let me just represent galvanometer with this symbol. Okay. Now third factor that we have taken is what? Is Rs. That is shunt resistance, resistance created by the shunt resistor. Shunt resistance. Okay. One more factor that we have used, the of specific factor is is. Now here I haven't written this factor since I have denoted this thing I minus ig as a single factor, that is ris, the current that is flowing to the shunt resistor. Or you could also say this thing that the current ig is when it flows to the galvanometer, the current passing through the shunt resistor is determined by is, that is equal to I minus ig. Okay, now back to the back to the factors. Now the whole thing that I have just discussed, we will showcase it in a really mathematical factor. Let's say here what we'll do, we'll first apply the product of first we'll apply the Ohm's law. OI V is equal to I into R. Okay. Now, first thing that you need to make sure, since we are not calculating here the voltage, so we'll convert it to the IR. Since we know this thing, V is equal to IR, so we'll simply say here that here the I that we are using is of G, the total current, and the resistance is also of the G, the resistance created by um, the galvanometer. That's equal to, we know this fact, that what is creating this thing, is it equal to is and rs, isn't it? Yeah, we know this fact that it is equal to the is, the resistance created by the uh, shunt resistor, and the current of the shunt resistor is also equal to the factor of the ig and rg. So we could write it as I minus Ig as well, since we need to find the value of the Rs specifically. So Ig would become equal to Rg, Ig, Rg, and this will be 1 minus Ig into Rs. Okay, now we'll transfer this to this side, and we need to find the shunt resistance. And let's say this would become Ig, Rg. Okay, let me just scroll it down. Okay, Rg, Ig, I minus Ig. That's equal to the shunt resistance. And that's all. How can we establish the equation for the galvanometer and the shunt resistor equal to the duo of the parallel connection? Okay, the factor that we use here is that voltage equal to voltage. Why we kept these two things equal, like is and rs is equal, since we know this thing, the voltage here would be r and voltage here would be of shunt resistance. I told you this factor, that the voltage in the parallel would remain same. Since we have equated the both things, so we got this concept that IGRG and the RSIS is equal. Okay, I hope this concept is clear to you, and thank you so much for watching this video.